In this video, we'll explore 5 must-use features of NumPy that will help you work more effectively with your data. Now, NumPy is a powerful library for scientific computing in Python. It provides a range of features that make it easy to work with large data sets and perform complex mathematical operations. From arrays and broadcasting to universal functions and masking, these features will help you unlock the full power of NumPy in your own projects. So let's dive in with number 1, NumPy arrays. Now, these are the core data structure of the NumPy library. They are multi-dimensional arrays that are designed for efficient numerical computations that are easy to create and manipulate. Now, suppose you're a data scientist working with a large data set of stock prices. You want to analyze the data to identify trends and patterns and to build predictive models. To do this, you can use NumPy arrays to store the stock prices and other relevant data, such as the dates and the times at which the prices were recorded. And then you can use the various operations provided by NumPy, such as slicing and mathematical operations, to analyze the data and build your models. In this case, the convenience and efficiency of NumPy arrays would make them an ideal choice for working with a large data set of stock prices. One of the key features of NumPy is broadcasting, which allows you to perform mathematical operations on arrays of different shapes. This can be very useful for vector and matrix operations, where you might want to add a scalar value to every element of an array or multiply a vector by a matrix. NumPy automatically broadcasts the smaller array, B, to match the shape of the larger array, A, before performing the addition. And this allows us to easily perform element-wise operations on arrays of different shapes without having to write manual loops or other types of complex code. Broadcasting can be very useful in many different scenarios. For example, if you're working with a data set of images, you can use broadcasting to easily add a constant value to every pixel in the image, or to multiply the pixel values by a scalar factor. This can be a quick and efficient way to perform common image processing operations. Another important feature of NumPy is the use of universal functions, which are functions that operate element-wise on arrays. These functions are a convenient and efficient way to perform common mathematical and statistical operations on large data sets. Universal functions are efficient because they operate on the entire array at once, rather than requiring you to loop over the elements of the array over and over again and apply the function to each element individually. This can greatly improve the performance of your code, especially when working with large data sets. Suppose you're working with a large data set of weather measurements, such as temperature, humidity, precipitation, that sort of thing. You want to use this data to build a predictive model that can forecast the weather for the next week. And to do this, you could use NumPy's universal functions to quickly compute statistical measures such as the mean, median, and standard deviation for each of the weather variables in your data set. You could then use these measures to help understand the characteristics of the data and to build your predictive model. In this case, the convenience and efficiency of NumPy's universal functions would make them an essential tool for your analysis. Masking is a powerful technique in NumPy that allows you to filter out elements of an array based on a condition. This can be useful for selecting specific elements of an array or for replacing elements that meet a certain criteria with a new value. This can be useful for all sorts of different applications, from data cleaning and pre-processing to feature selection and engineering. Now, suppose you're working on a data set of customer reviews for a product. You want to use this data to identify common themes and trends in the reviews and to build a model that can classify new reviews as positive or negative. To do this, you can use masking to select only the reviews that meet certain criteria, such as having a certain number of words or containing certain keywords. You could then use these selected reviews to train your classification model and to gain insights into the common themes and trends in the data. In this case, masking would be a useful tool for selecting and pre-processing the data to prepare it for analysis. Now, NumPy includes a number of functions that can be used to perform linear algebra operations, such as matrix multiplication, inversion, and decomposition. These functions can be very useful for working with matrices and vectors in scientific computing and data analysis. NumPy's linear algebra functions are efficient and well optimized, which makes them a valuable tool for anyone working with linear algebra in Python. Linear algebra operations are often used in many different areas of science and engineering, such as machine learning, computer vision, and signal processing. In these fields, linear algebra is often used to represent and manipulate data, and NumPy's linear algebra functions provide a convenient and efficient way to do this in Python. NumPy is a powerful library for scientific computing in Python that provides a range of useful features for working with large data sets and performing complex mathematical operations. And another Python library that has a great bunch of features you should know about is pandas. And to see how pandas and NumPy compare, watch this video.